So in the previous example, we chose a sample size of 100,000 because we thought it was a nice, big, round number. We're going to talk now about how we can do this completely differently. That is, rather than choosing a sample size of 100,000, I can say, what if my total is 1? Now I'm going to fill out the table exactly like I did before. That is, I know that 57% of college students are female, so 57% of 1 is 0.57. I also know 43% are male, so this right here is 0.43. And I want you to notice right off the bat how this table is different than my one up here. In the top table, I had 43,000 here. Now I have 0.43. Here I had 57,000. Here I have 0.57. Essentially what I've done is I've taken each of these numbers and divided off the 100,000. So that's 43 divided by 100,000 would give me 0.43. 57 divided by 100,000 would give me 0.57. And so based on this, rather than recalculating all these probabilities like I did before, what I'm going to do is I'm going to copy my numbers down here. That is, this will be 0.3192, 0.2508, 0.1677, 0.2623, 0.4185, and 0.5815. And once again, why I'm doing this here is I'm using a sample size of 1 versus 100,000, so everything's going to be divided by 100,000 to get it down to the level I have at this table here. Now I want you to notice that my probabilities are the same. That is, based on this top table, I could ask you, what's the probability that out of men, someone did not take out a loan? So that is, out of guys, what percent did not take out a loan? And to find that, you tell me that the total number of males was 43,000. And out of those 43,000 men, 26,230 did not take out a loan. In decimal form, that's 0.61. So 61% of guys did not take out a loan. Now, down on this other table, let's do the same thing. That is, let's ask ourselves, out of men, what percent did not take out loans? To do that, I'll go ahead and I'll say, well, in total, I have 0.43 for men. And in that male column right here, I have 0.2623 did not take out loans. When I divide that off, sure enough, I get 0.61 or 61% here as well. That is, I'm going to get the same results off both these tables. The advantage of the table in the top left is I get nice whole numbers. The thing about this bottom table is this contingency table is actually made up of the probabilities themselves. So the probability of the entire thing is 1. Probability someone does not take out any loans in total is 0.5815 or 58.15%. Total percent who did take out loans, 0.4185. The numbers in the center here, if we choose one of them, let's go ahead and say we have this number right here. This tells us that out of our entire sample, 31.92% of those people were female and did not take out loans. So that is, the table on the bottom is actually giving me all the probabilities on their own. So I can either do the top left and have nice round numbers with this made up sample size, or I can do the bottom right, in which I use 1 as the total number and come up with the probabilities on the table. Disadvantage, ugly decimal places. Advantage, I get the probabilities right off the bat.